In this lecture, you will learn the basic concepts of containers and Docker. Let's get started. Let's start with a practical example. You want to create a service that exposes REST APIs using the Flask web framework. Since Flask is based on Python, you will want to first install a specific version of Python, such as 3.0. Then you will install Flask on top of it. You may need additional libraries to support your REST API development, such as the Python sockets library. Finally, on top of this, you can develop your Python script file api.py that implements your REST APIs. Two problems arise if you manually configure this setup. It is hard to replicate. If you want to build this setup on another machine, you will need to repeat the same installation and configuration steps of the operating system, frameworks, and libraries. This is hard, error-prone, and time-consuming. You also have version conflicts. If you have different versions on the target machine of some of your dependencies, for instance, one service needs Python 3.0 and another service needs Python 2.8, your services may fail due to the conflict between different versions of dependencies. Wouldn't it be nice if you were able to put your application in a box along with all its underlying dependencies, have it isolated to avoid dependency conflicts, and easily ship the box around to another machine? A container does just that. Now, let's distinguish between two related but different things, namely a container image versus a container. A container image, or image for short, is a read-only template with instructions for creating a Docker container. Each instruction adds a piece of software to the image. This is called a layer in the image. Going back to our Python example, the image will have the following layers: the operating system image, Python 3.0, Flask, Python socket library, and the application source code in the api.py file. Please note that the operating system image is not an actually running guest operating system. It is just a collection of binary files for operating system commands and tools that can be run using the operating system kernel on the Docker host. In other words, we do not have the runtime overhead of a guest operating system. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker API or command line interface. It is a process isolated from all other processes on the host machine. It has its own file system, which is cloned from the container image, and it even has its own IP address. This isolation is possible using features in the operating system kernel. So remember, a container is an instance of a container image. Let's take a look at the Docker architecture. Docker uses a client-server architecture. The Docker client, Docker, talks to the Docker daemon, Docker-D, with a D at the end. The Docker daemon does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same host, or you can connect a Docker client to a remote Docker daemon. The Docker registry stores Docker images. Docker Hub is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. For more information on Docker architecture, refer to the Docker overview link in the resources attached to this lecture. Let's compare containers versus virtual machines. Containers are an abstraction at the application layer that packages code and dependencies together. Multiple containers can run on the same machine and share the operating system kernel with other containers, each running as isolated processes in user space. Containers take less space than virtual machines, typically tens of megabytes in size. Containers start in a few seconds because a container is just a process tree on the host operating system. And since there is no guest operating system overhead, one host can handle tens or even hundreds of containers. Now let's look at virtual machines. Virtual machines are an abstraction of physical hardware turning one server into many servers. Each virtual machine includes a full running copy of an operating system called the guest operating system. Therefore, a virtual machine is typically tens of gigabytes in size, and because the guest operating system needs to boot, a virtual machine can take a few minutes to start. And therefore, one host can only run a few virtual machines due to the overhead of the guest operating system. This does not mean that containers are better than virtual machines. Since containers share the host operating system kernel, they have less isolation than virtual machines, which has its drawbacks. As an example, a Docker engine on a Linux host cannot run a Windows container. You actually can have containers and virtual machines work together. To learn more about containers and how to have containers and virtual machines work together, refer to the "What is a container?" link in the resources attached to this lecture. Do not worry if this seems like too much information at once. This is just an overview, and we will tackle each item separately later in this course. You will have several labs to apply the concepts of containers and Docker. Head over to the next lab to containerize your first Docker application